Welcome you all. Myself Benay Selvanesan. In this video, we will see about the value-added courses on embedded C programming from EC department, Rohini College of Engineering and Technology. In this value-added courses, we will see about the operating system versus embedded system, and then usage of high-level language, and then assembly language versus the C language, and then difference between the conventional C and the embedded C, and after that advantages of embedded C, and then why C language for embedded system, then compilers of cross compilers, then bitwise operation and startup code, then redundant function and volatile modifiers, then finally we will see about the roots for embedded C programming. Operating system versus embedded system. Operating system creates an environment where a user and the computer may interact with one another to perform a huge variety of tasks. So operating system is doing a huge variety of tasks, but embedded system will only perform one type of task, and it will often do it without any intervention. So in operating system, the non-embedded concept, the processing is of main concern and the input and output. So in embedded, it is the input and output that it is important, and processing serves only to connect input with outputs. Operating systems are not closely tied with the hardware, but it manipulates hardware register for memory management, task process, switching, interrupt request, etc. In embedded systems are closely tied to the hardware throughout the system. The system consisting of manipulating the hardware registers. So, developing a program in C involves large memory caches, virtual memory, registers, etc. So, but in embedded system have limited memory space and registers. The above parameters have to be considered in designing an embedded system. So next, usage of a high level language. Normally we are using a high level language mean we are considered as a C level language. So C being a high level language and a familiar language among the programmers, it has become the first choice. So language is a C or EC in coding because they are more reliable programs and they have increased programmer productivity and portability across hardware. So C language has its reputations increased and it is also implemented in operating systems. So next, assembly language versus the C language. So normally we are high level language, we are using a C language. So now compare with the assembly language versus the C language. The assembly code are difficult to read and maintain. The amount of code reusable from assembly code is very low. So C programs are easy to read, understand, maintain, and process greater structure. With the C programmer need not know the architecture of the processor. So we can develop a language only. So code developed in C will be more portable to other system than the assembly language. So assembly language is difficult to read and maintain. So now comparison between the assembly and embedded C program. Let us see the one example. Here in left side, there is a assembly language. There is a origin, and next we move the content of 05 to a register R1, and then move 06 to a R2, and then R1 content is moved to a accumulator, then add accumulator content with the our register R2, then result is stored in a accumulator. That's the result. The result is moved to a R3. There is a move R3 by comma A. This is assembly language. When we rewrite this in a embedded C language mean we have a main, and next we define a integer variable a, b, c. A is assigned to a 5 and b is assigned to a 6 and c is a add a plus b. Then we need to move a printf to a c. Next, difference between conventional C and embedded C. Here compilers for conventional C are TC and BC. Compilers for embedded C are Keil Microversion 2 and 3, PIC, C, etc. So conventional C programs need compiler to compile the program and run it. The embedded C program need a cross compiler to compile and generate hexa code. The programs in C are basically processor dependent, whereas the embedded C programs are microcontroller dependent. Next, bit level programming and optimization. Embedded C normally offers a unique concept of bit level programming. This concept is mainly used to declare a variable that will be stored in the bit addressable area of data memory. This is very useful because the variable declared in this fashion directly points the data in a particular segment of memory. So structures and unions are possible in bit operation. The bit of the variable can be accessed without using previously declared bit names. So now we want to one example. It can be defined in a simple way. We are defined that is unsigned characteristic b data, that is a is equal to 10, and then bit variable is a b, b a XOR with 3, and we will get that is a b is equal to 1. After the final execution, the value of b is a 1. And bit level programming limitation, here a bit pointer is invalid and the array of bits is invalid. Next, embedded software development. The embedded software development tools cannot make assumptions about the target platform. The user has to provide some details of the system to the tools through explicit statement or instructions. Once these data are given to the tools, these tools generate the accepted outputs and the computer system itself so that the programmer can analyze or make suitable changes in the software to get the desired output. So this is an example. So here that is a include register 51.high unsigned volatile character time. We define the main time is equal to 0 while time is less than the 100, wait for 100 counts. Otherwise it does not wait. Void auto update time is equal to time plus 1. It is increasing the time. Next, identifying error levels during compilation. There are the 3 different categories in identifying error levels during compilation. These errors are assembling. First one is a assembling, and second one is a compiling, and third one is a runtime. The assembling errors are caused during the assembling of the source code. The compilation errors are generated during compilation. The above 2 errors are caused due to the syntax error in the program. These errors are generated by the compiler for the user's reference. The errors and the reason for this are provided as a help to the user in Keil library function. These are described under the heading as A51 assembling errors and C51 compile time errors and linking errors. So next, runtime errors. The runtime errors are caused during the linking of the source code. The runtime errors are generated during runtime by loader. These errors are not highlighted during the compile time because these errors do not affect the compiler because while generating object code. So these errors are caused when the processor cannot execute any instruction which are used in the program. The errors on the reason for these are provided as the help to the user in Keil library function. Generation of compiler output files. A compiler mainly translates program written in a high level language into a equivalent set of opcode for a particular processor. Each processor has its own unique machine language. A compiler that runs on one computer platform and produces code for another is called as a cross compiler. A compiler produces a series of files called as a object file. So cross compiler, this is a flow chart of a cross compiler. Compiler uses an operating system as a platform. It's doing edit the program, compilation, running and execution output. When we are using a cross compilers, that is the uses of operating as a platform, edit the program, compilation, use the second platform in hardware, execution and output. And next object files. After the C file is compiled, object file or generated, these files are used to in link with other object library files to generate the absolute object file. To invoke the linker L51 has to be used. The structure of these object files is defined by a standard format like COFF, there is a common object file format, or ELF, extended linker format. So cross assembler is also a compiler. It is also used to assembly language compiler. The assembler compiles and generate object files for an assembly program. Only these assembler produce the same object file as a C compiler. Next, debuggers. These are used for the step-by-step execution of the program. In this, for each execution in steps, the debugger operates on a object code generated during compile time. Linkers, the different object files generated by the compiler are linked together to form a new object file. This file contains all the code and data from the input object files or in the same object file format. Map file generated by the linker gives information about absolute object file. So next, locator or loader. The tool that performs the conversion from relocatable program to executable binary images is called locator. The input to the locator is the information about the memory on the target address. The locator uses the information to assign physical memory to each code and data section within the locatable program. It will then produce an output file that contains a binary memory image, can be loaded into the target ROM. In 8051 ARM or ARM processor, the locator is built in the linker itself. The memory information required by the linker is passed in the form of a linker script. The script informs the linkers built in a locator about the memory on the target board and instruct it to locate the data and BSS sections in the RAM. The result of this final step of build processor is an absolute located binary images that can be downloaded to an embedded system or programmed into a read memory devices. So rules for developing an embedded C program. First one is a code optimization. In the code optimization, there is a minimize local variables. The number of local variables in a function is less, the compiler will be able to fit them into a register. Hence, it will be avoiding frame pointer operation on a local variable that are kept on the stack. This can result in considerable environment due to two reasons. One is all local variables are in register, so this improves the performance over accessing them from memory. If no local variable need to be saved on a stack, the compiler will not incur the overhead of setting up and restoring the frame pointer. Declare local variable in the innermost scope. Do not declare all the local variable in the outermost function scope. If local variables are declared in the innermost scope, if the parameters were declared in the outermost scope, all the function calls would have incurred the overhead of the object. Next, place case labels in narrow range. If the case labels are in a narrow range, the compiler does not generate if cascade for the switch statement. Instead, if generate a jump table of case tables along with manipulating the volume of the switch to index the table. This code generated is faster than if else if cascade code is that is generated in case where the case labels are far apart. Also, perform of a jump table based switch statement is independent of the number of case entries in switch statement. Reduce the number of parameters. A function's calls with the large number of parameters may be expensive due to large number of parameter pushes on stack on each call. For the same reason, avoid passing complete structures as a parameter. Use pointers and reference in such cases. Use references for parameter passing and return value for types bigger than 4 types. Passing parameters by value result in the complete parameter being copied onto a stack. This is a fine or regular types like a integer, pointer, etc. These types are generally restricted to 4 bytes. When passing bigger types, the cost of copying the object on the stack can be prohibited. When the functions exist, the destructor will also be invoked. This is too efficient to pass reference parameters. This way you save on the overhead of a temporary object creation, copying and destructions. This optimization can be performed easily without a major impact to the code by replacing pass by value parameters by constant reference. Passing bigger object as a return variable also has the same performance issues. A temporary return object is created in this case too. So it is important to pass constant reference so that the bug in the called function does not change the actual value of the parameter. So use all the SFR in capital letter only, reduce the warning in the program, make use of a macro definition in the program. Always define the variables in the code memory by using the keyword code declaration. Example, unsigned integer code A equal to open bracket. Always define an unsigned type of a declaration. Make use of a S bit definition for single bit declaration. Example, S bit is RS is equal to B3 XOR with 6. Since these are not floating point coprocessors, so no decimal values can be given as a input to them. So we cannot define the above declaration as a S bit as P3.6. The declaration like this below are invalid. P3 ampersand 6 is equal to 0. P3 6 is a bit addressable type and 0 is a 8-bit data which cannot be stored in a single bit. So permanent termination of the program is got by using while. Infinite loop can be achieved by while. It is a while looping. Thank you.